My name's Brett Hoerner. This is Solr at scale for time-oriented data. Get started here. About me really quickly. I'm actually local here to Austin. Used Solr since 2012. Only use Solr Cloud. I want to be clear, I'm not a contributor. Take everything I say with a grain of salt. It's important, I guess, in my presentation that I've pretty much only worked for startups focused on scalability. Which also means I am the DevOps guy. There's no team of DevOps, like I've heard mentioned, which would be really nice. There's no anything like that. I index things into Solr, I read from Solr, and I am the guy that's paged at 2 a.m. when it breaks. Quick plug, I think I even saw Radu come in. This talk was really good last year, really kind of related to mine, so I'm gonna not focus too much on tuning, more of a case study here, some products I've worked on, so the notes will be online to find this. So quick overview of where I've worked and what I've worked on related to this talk. I worked for Spreadfast. It's a local company here in Austin. Software as a service, social media marketing. They had a partner with multiple social networks, so full fire hose of data, right? We want to put the whole thing in Solr to make products out of it. One example collection out of many, 150 billion docs spanning a year, average of 10K writes a second. Those include updates and deletes, so not necessarily 10K new docs a second, but 10K writes. A decent amount of fields per document, 800 shards in Solr Cloud, all this on 13 machines in EC2. And again, the entire Solr team is 1 to 2 people, depending on what the other people had to do. Of course, there's people above this that write the actual product, but the Solr part was pretty much me and some other guys. This is a kind of washed out example, but just quick, you're doing search, you're getting social media data back, tons of faceting. You can kind of guess where it goes from there. It's just people want to look back 11 months on what happened on Facebook at this time, kind of things like that, trends. Another example, geo heat map. You can zoom in and out, which requires multiple fields for it not to kill your Solr cluster. You can animate it, it's pretty cool. So that's just an example of like one of the clusters, what it actually powered. So today I'm at Rocana. It's root cause analysis for complex IT operations, meaning basically it helps you monitor really, really large data centers. It's not SaaS. We actually ship software to customers. They run it themselves. Of course, we help them run it. It's used to monitor hundreds of thousands of machines at once. And I guess the point, again, to kind of give context to my talk, people that buy our software really care about a minimum about a terabyte a day of logs. And we're in the Hadoop ecosystem, so we're not just search. That's one of our pieces of our product. Use a lot of the tooling in Hadoop world. A lot of our founders are from Cloudera, so that makes sense. And again, I'll get into that a little bit more. Again, a quick, everyone's seen log search before. I'm not going to give you a product tour, but this is like one piece of it, so just to let you know what I'm talking about. Okay, so what's similar between like these two systems and other systems that I feel like I'm kind of talking about in general here is that each like log line or social media post becomes a single doc in Solr, of course, so that you can do facet counts and things like that. What's kind of odd compared to, for example, the keynote this morning is that relevance very rarely comes up in conversations when I work on these products because what they want to see is, again, the graphs, the trends, and you almost always want to see things sorted by time because that's how you want to like see log messages ordered. I can't think of a single case where I actually used the Lucene or the Solr score boosting or anything like that. So in a way that makes this a lot easier, kind of like he said. We're pretty much only concerned about scale. Can I return the results? Can the person find those log lines they need? Can they see the graph of the trends? Can they look back 2 years and see the same graphs over billions of documents? Queries, of course, because it's graphs, tons of faceting. And another unique thing, this pretty much all has a time range. If every document has a timestamp on it, every single query that comes in has a timestamp range on it that's like from 1 to 2 or 3 to 4 or whatever. That's always there, and I'll get to that somewhere also. Quick, just aside that these are generally part of a larger system. Just want to recommend Kafka to people, but when you're dealing with the fire hoses of data, or worse, like not a fire hose, but 10 or 100,000 hosts that are each sending maybe 2 log lines a second, you really want to aggregate those so that you can do batching and things like that. I'll, again, bring this up again later. This little example here is just showing the simple power of collecting all your data in Kafka, pushing it into Solr with one system, which you can now easily upgrade that system. You can turn it off and on, and it'll pick up where it left off in Kafka. Completely separately, another system is pushing it into S3 to keep those logs forever, right, just in case. And again, more foreshadowing. Okay, this is pretty much a little bit the only part that I'm going to duplicate from Radu's talk. Just the big ones to think about when you're kind of dealing with maybe scalability, because I'm going to assume here that if you have billions of documents, you're probably writing 10K a second or something like that. Obviously, your Java heap, but make sure you leave room for the OS page cache. RAM buffer size, another obvious one. That's how much it'll keep in the JVM heap before it flushes it out to the segment. So your hard commits, I would crank those up to minutes, 5-10 minutes if you can, and not open a new searcher. The biggest one is the soft commit. I say as high as possible. What that means is as high as like your product team will let you. These are my words, not my company's words, but I think that you can do 15, 30-second soft commit and still say the word real time, but some people might not agree with that. To me, if you're indexing 100K events a second, the idea of doing a soft commit and reopening a reader every second is insane, and you're gonna tear up your cluster that way and not really get much human benefit from it. So anyways, that's the one you gotta argue with product, because that affects your life a lot, right? Merge factor, I just put that in there. I'm not gonna make any recommendations, just look into it. And of course, batch your writes. That's, again, really important from this example. If we got rid of Kafka and we had 10,000 hosts, each individually connected to and hammering Solr with a whopping 2 documents each per second, it'd just be insanity. I don't think it would work at all. So you want to kind of get all that stuff together. Kafka, Flume, whatever you want. Do batching. I'm not going to recommend numbers here because everyone's document sizes are different. Everything, you got to kind of figure that out. Just a recommendation. Let's see. Query side, again, this is just the brief kind of basics here. Make sure you use doc values, anything you sort and fasten on. The only thing I warm on is time, because for the log search and social media search, there's not like a term or anything that I can't, it's not like Zappos, I can't like pre-warm shoes or something. There's no query that's really helpful. I don't know what people are going to search for, so I kind of leave that to the minimum. And in the same vein, I use a very small filter cache, because when you have billions and billions and billions of documents per JVM, your bit sets for the filter cache are huge. You can do the math on that and figure out that like if your filter cache was 100 items and they were all, and there was a bit set in each one of those, you're talking gigs of a JVM heap immediately just put to the filter cache. And then the chance of those being hits is really low. Like who's going to come in with exactly that timestamp query, that start and end, like down to the second or millisecond, except for the user that's already on the page. And so one thing I do recommend is do filter cache the time range, because for most products, you land on the page, you have a search, and maybe you like keep tweaking your query. Like Zookeeper, oh, okay, Zookeeper warn, Zookeeper blah. And you're kind of coming back with that same timestamp window. You're looking at the graph, and you're just kind of changing it as a user. So one of the few things you probably can cache is time. Again, totally depends on your product. This is just kind of my experience. So the most important thing, getting the meat of it here, is like sharding by time. Hopefully everyone knows that like Solr just sort of hashes your unique field that you define in the schema, decides which Solr Cloud shard it gets sent to, so you're kind of evenly distributing your documents, which sounds pretty good if you have 10 shards, but if you need to scale up and you have 800, now you're fanning out your writes everywhere. You're keeping every shard like mildly active, and they're writing new segments. They're doing merges over these really kind of small segments. If you're writing 10K a second to 100 nodes, what is every shard getting 100 docs a second or something, which is really small. So you kind of want to, like, in my opinion, funnel those things. But it's worse on the read side, because it means that every single query you send to your system has to go to every single shard, because you have no idea where anything is, right? A search for Zookeeper literally has to go to every box. More importantly, a search for Zookeeper in the last 30 minutes has to go to every box. That's stupid, right? So this example query, searching for the word happy for a very specific given range of time, is going to send out, if given 500 shards, send out 500 requests to the different Solr shards. Each of those is going to do the search on their individual core. The coordinator, I call it, is going to wait for 500 responses. It's going to merge them and respond. The overhead of that is insane, right? So the the real solution here is to take control of document routing. I'm sure a lot of people here know this. It's just, in case you didn't, you can define your router when you create a collection in Solr Cloud. It's the router that you want to use is called implicit. I think that's really confusing because to me it's you're being explicit, but I've never understood the name. But anyways, you say implicit, now you cannot say create me 10 shards. You actually have to name them. And so in this example, and this is what I do personally, but you can do whatever you want. My shards are named by the UTC midnight of the day, and so this example here is day shards, so 1 shard per day. And I put the ellipsis there because you could create 800 of these at once, which is fine. Of course, the next question is like, okay, what happens when the 800 days pass? You obviously need a system here now, which cron job or whatever, right? That's creating new shards in the future as days roll over. Getting an empty shard ready for adding documents to. And on the back end, you're probably going to be dropping shards, which is another benefit of the system, is that instead of a query delete where you're really thrashing like the delete bit set in Solr, which is or in Lucene, which is pretty dangerous for performance. Now you can just say like after 366 days, drop the oldest shard. Just literally shard delete, and it's basically free. It's just deleting files from the file system, and you move on. So with those, with these 3 shards created, simple example. You have an event come through Kafka or your system, whatever it is. It was created at this very specific timestamp. You truncate it to the UTC midnight to figure out what day it belongs in, and then that's your shard name. So we're going to assume that the day that we're in is the 3rd day there, which I think is actually tomorrow, but whatever. And most of your docs can be flying in there because we're assuming kind of real-time system here. So that core is going to be getting a shard, a core, whatever, is going to be getting the majority of your writes. Of course, old docs can still come in and the system still works because you just calculate the route out and it goes to the right place. You can, of course, I don't know what you call it, sub-shard here, where instead of defining 1 shard for the day, you could find 1 and then have 4 per day, and you could have like _0, 1, 2, 3, and then you truncate the day, then you hash the ID and modulo for it, right? So that you're splitting up your writes if your writes are too heavy for 1 shard. This is pretty easy to figure out. Hopefully, just the general ideas, what I want to get in people's minds. So this doesn't necessarily help your write side. It doesn't really hurt it in my opinion either. The benefit isn't on the writes. The benefit is now someone says, hey, I want to search for hello across these 2 days, and here's like these very specific timestamps. You truncate them down. This example, I kind of realized last minute was a little poor. I should have had a gap day in there because your code obviously needs to figure out what are my ends, and it needs to fill in the shards in between, which you have known logic here. If you have a shard per day, then you just need to fill in, like enumerate every day in between the points. And now I know I need to hit 2 shards, 1 shard. You could hit 800 shards this way. That problem isn't solved. That's again a product thing where you have to figure out what you're willing to spend to allow people to query at the same time. Generally, like for Spreadfast, I think it was like you can only really query 2 months at a time, a wide range. You could, front end team could figure out like query a month at a time and build out the page for you. It would take longer, obviously, but you can't. I've never found a solution that's cheap where you can literally query the entire collection at once when you're talking about 150 billion docs. Anyways, so this is the solution to the the big solution to the query side. This makes over 150 billion docs. Our pages, those pages look all pretty graphs load in like sub-second, which is really nice. Okay, so now you're partitioning by time. Another obvious thing that I've done most places and with most of these collections is have a duplicate cluster that's for your hot set. In most of these systems, logs and social media stuff, most people are really looking at the last week or whatever. So when I say more hardware per document, imagine you had 12 servers for the 12 months, 1 server per month. Now, for 30 days, you might give it 4 of the same size servers, right? Which is a hell of a lot more. That's 4 times more, hardware behind that cluster. But it just means that that hot set is a lot faster. Most of your queries are going to go there, 95% or whatever, probably. And then, again, I guess I didn't mention, but like this logic here, I'm assuming that you're not letting your customers literally just hit Solr. It depends on your product again, but you're probably going through your Django web app or your Rails app or your Java app or whatever, right? So this is where that logic happens, is where that gets tacked on. The same thing here. It's like, oh, what's that range I queried? Is it last 30 days? All right, cool. You know, send it to this collection, literally just a different HTTP endpoint, right? If it goes over it or if it's outside of it, then send it to the bigger one. Really simple thing. Really helps with just keeping the cost down on this long tail. You know, having the long tail probably, if you're in this talk, is really important to you, but most people are not querying it all the time. So it's awesome to have this. This is a definite aside. I don't think I had time to talk about this, and I have to talk about this later, but one of the things, so like at Spreadfast, I had a small Solr fork. Again, mostly because it's a team of one, and I'm also doing the ops. I wish I could contribute it back, but to make this general and not very specific would take a lot longer than it took. It's like something like 100 lines of code. The gist is that you know, you can remove that. Let me go back to this example here. If you did a query from for the first all three buckets, and or shards, it needs to hit all three. The one in the middle, you don't need to send that timestamp, the created at part of the query to it all. You don't need to blow out the filter cache. You don't need to make it do the work to make the bit set and do the you know, bitwise and, right? Because you know that day only has that shard, everything in there belongs in that day. So you can just skip doing the work of having it calculate that. Only the shards and the ends need to do that math. Not math, but you know, to do that check. In addition, you can truncate, like when you send it to the shard on the left, you can truncate the right side of the 2 to be just star, because you know that it only goes to the wall there, and that means you're going to get more cache hits. There's all kinds of tricks with this. Again, this is very specific to Spreadfast. It's like, I know that a shard is called this, and that means it's a day, and I can do this, you know, that's why it has hack in the name. That link goes to a GitHub page, like that is the branch that I created. And it's in production. And then this really gross thing at the bottom that if there's any committers here, they're probably groaning, but it's like a flag at query time that you could disable facet refinement. I'm trying to think of how to describe that. For anyone who doesn't know, like when you do a facet, if there's some numbers that are kind of ambiguous, you don't know that you got them back from a few nodes, but not the rest, and it could possibly add up to belong in your top set. It actually has to go to all those, it goes back to all those shards and says, yo, can you give me like the real count for these so I can figure out the true right answer? We had this saying, well, I don't work there anymore, but I had this saying, I would just say, it's just tweets. Like a lot of times people just want trends and they don't really need like the exact number of Justin Bieber tweets that's in the thing. And so this turned like 3-second queries to like 300 milliseconds a lot of times for us. And so it was an option, and you know, we hit it in some places where it didn't matter to us, basically, or where you're gonna like truncate the number anyway and say 13K instead of 13,741. Just a handy hack. There's lots of hacks like that you can probably define when you start digging around. Okay, so totally kind of different topic. Replication at this scale. At Rocana, we actually do Solr on HDFS. Again, I said we're in the Hadoop ecosystem. That makes it easy. When you're writing your index, it gets replicated. You're literally writing it into HDFS. That's where it's being served out of also. So when a node dies, another Solr node, and this is actually part of Solr, thanks to Mark Miller and Cloudera, I guess, that a node dies, another node can just be like, oh, cool, I'll just literally open this file off the global file system that I'm on, right? And it's kind of magic. But for everyone else, you're stuck with normal replication, which just couldn't keep up with us, couldn't keep up for us, or we couldn't keep it up, or whatever. And so it apparently made it a lot faster in 5.2. So you should check it out. But the big thing I want to instill is that replicas aren't backups. When you're talking about 100 billion docs and like a programmer error, you send a delete query or something, you know, who knows, right? You lose that thing. This isn't like the, oh, okay, we'll just do the Python for loop that hits Postgres and we'll reindex it, right? You're talking about 100 billion docs, right? Very scary to lose your data, which is what I wanted to get into. For anyone who went to the Walmart Labs talk, there's a little bit of overlap here, but I'm not going to go into the details. So you have a 100 billion document cluster being generated. And now, you know, again, this is the log case at Rocana, for example, is a little bit simpler so far. You don't really need to change your schema on logs too often. For a product like the social media stuff, all the time there's like, wait, we want to add a new field that our guess at the person's gender. We want to add a new field that's our guess at the person's age. We want to get their follower count at the point in time of the tweet so we can do all kinds of weird sorting and scoring. That comes up all the time, nonstop, right? In addition, just changed things like maybe programmer error, maybe I indexed the wrong thing. Catastrophic data loss is one I mentioned, and then upgrade Solr with no risk. As another side, I would totally upgrade Solr, at every 0.1 release that comes out. I think from 4.0 to 5.3, we were getting, I don't know, just average like 10% free performance at time, per release. Might as well, right? So all these things are really important. Again, if you're doing product stuff, user-facing things, you're going to get requests like this all the time. So we do 5K docs a year, per second for a year. That's 157 billion docs. So let's just say our cluster can ingest 50K a second. If we wanted to push it a little bit, the math on that is, over a month to reindex. And that's every time your boss comes to you and says, we need a new field, or every time the data science says, hey, we have a new model, we can detect some new thing on Twitter, right? So you either, you can do this. You can push all your data back through Kafka and let your normal indexers do this, and I did that to start with. But nothing can go wrong, right? Because you're already on a timer for 36.5 days. Which is, I don't know, you need to talk to your, if you ever have a PM come talk to you and you tell them 36.5 days, it's pretty hilarious. So this is the overlap from the talk earlier, if you went to it. There's a tool called MapReduce indexer tool, really powerful. Given the raw data, which is the throwback to, this is a good reason to use Kafka or Flume and always shove your data into Hadoop, HDFS or into S3, somewhere where you might as well keep the whole stream. You gzip that, it's going to be minuscule cost per year, and you're going to use it all the time, I promise. So given that, you have a MapReduce job that can take the raw data and generate a full, basically, Solr collection. Again, I'm not going to go into details on this. The Walmart talk went into some, and I just kind of leave this as an exercise to the viewer, but it's really powerful on Elastic MapReduce using spot instances, relatively cheap. The job is written for you, so you just kind of have to learn how to use it and plug it in, and you spin up EMR, you run it, you make a new collection, you turn it all off, right? This is going to be a lot faster in 36.5 days. The annoying thing is that it just creates a bunch of cores that are sitting on HDFS. The tool doesn't yet, it'd be kind of insanity, I don't know how it would know to do this, but it doesn't yet know how to find where your boxes are, which ones are the right ones to find, where to put every shard, how to load them into the Solr collection. Unless, of course, you run an HDFS, it's nice because it can literally just, it's put on HDFS, it can now just make a call to each Solr node and say, hey, here's some files in this directory, index, merge them, which it does. The go live is an actual feature. It's a nice benefit if you take on the pain of running Solr and HDFS. But as an example, at Spreadfast, my former colleague there has this down to 150 billion doc index. That's 1 year. Takes about 6 days now for about $3,000. And that 6 days isn't just doing the index. It's also moving them, and the cluster is running. You can send queries to it. So you deploy your web app to point at the new cluster, and you just EC2 stop all the old nodes, right? So it's a switch over. 6 days is awesome. I think they do this all the time now because, again, data science, new fields, or whatever that you want historically on all your old data, you can't do that without basically reindexing. And he's mentioned that he wants to open source it, so you should bug him. Let's see. So yeah, those are the things I wanted to go over. Optimization at that many documents matters more than probably any other normal Solr cluster, especially thinking about RAM. For us, that was most scarce. I think I mentioned at the beginning the 150 billion docs was just on 13 nodes. If someone did decide to light up Solr with query every month at the same time for a really common keyword and do facets, it does our cluster. That's an unsolved problem because we're just not willing to spend the money to make that impossible. So we just protect it by people can only query certain ranges and things like that. So that's why you got to turn down your filter caches and things like, just conserve RAM where you can. Obviously, shard based on time. Hopefully that was kind of obvious, but maybe people didn't know about the fact that you can do that in Solr today. And then, to me, the biggest takeaway and things for people is just that unless you have something that's never going to change, which I can't think of an example. Someday someone's going to say, I want a new field, and you're talking about billions of docs. You have to have a way to rebuild that and iterate on your basically your product. So that's it. Open for questions. Yeah.
As your older shots are basically immutable, are you doing an optimization of those?
You can. At Rocana, doing like syslog stuff, I would say they're more immutable, and we can and should probably do that. And I know I have friends that do that. For social data, updates actually go back in time and touch the stuff all the time. Although it still helps to do it, right? So like maybe like a week after you should optimize. Yeah, no, that's a freebie. Definitely recommended. That's probably just some outside system cron that's kind of like looking and doing that, sending those optimized queries out. Yeah. Yeah.
If I remember correctly, you guys were running like multiple Solr JVMs per box.
Yes. So I meant to. I didn't know if what is my actual time on the thing? Okay, perfect. So I wanted to add some slides for the backup, but I didn't get time to. This is a weird one that people seem to think it's weird, and maybe I'm really odd for this, but so these 13 boxes for that one cluster are the C3s or something, and the 256 gigs of RAM, right? We would run, I think it was 8 or 16 Solrs per box. We found that in a single JVM, you can only go so far. You're going to fight the GC. You're going to fight the pointers getting much larger if you go over 30 gigs of RAM. We were on SSD, and the other thing is that we would stripe our data. I don't know if that's the right word for this, but you're talking about 13 boxes, 16 JVMs per, and you're talking about time series. So what you want is we had 12-hour shards there. That's why, hence the 800 for 13 months is what we had. Each day or each 12 hours needs to go in another box. You never want to keep like just filling up the box until you're full, because now when someone sends a 7-day query, you're by definition hammering the hell out of one box. So you want to put 12 hours here, 12 hours in the next box, 12 hours in the next box. So we striped them. We had multiple JVMs per box. I never ran into problems with that. I really enjoyed it. The way I worded it, a friend of mine said, why don't you just run 16 smaller EC2 boxes per box that you pay for, because EC2 is very linear pricing. To me, the benefit is that when a query comes in, I get the burst up to the full speed of that box. I get all the RAM in the world I want. I have 32 cores, and I have everything, whereas if you're actually split it up to one JVM per smaller, like if we had 16 times as many nodes, they can't take advantage of the hardware that you basically are already paying for. So I'm a big fan of big box and put as much stuff on as possible. Was there any specific question, or do you just want?
No, and another thing,
Yeah.
You are maintaining all the metadata in your application. What time range is where, and when the query comes in, you are figuring out like which shard holds the query all in your application.
Right. Yeah, so that query example back there, like I mentioned, that's actually in Rails. So there's a front-facing API that makes sure that you're paying us money and things like that before it lets you in. And that same place is turning a much simpler JSON query into the actual Solr query. And yeah, doing the routing of, should I go to the fast collection, should I go to the slow collection, which shard do I need to throw into my query to make it work, et cetera, et cetera. Yeah.
So on Linux, you can configure replicas or not?
And on Hadoop?
When you leave it, right, so you define one shard per day, right? Do you have a replica for it?
No, we don't.
So what happens when it will go down?
So that's another reason. So that's another reason to have the reindex thing on hand. I left there a year ago, and that was definitely a red flag, right? That's a scary thing. The same guy Adam has worked on a system that is using we're talking like Solr 1.4 here, using the old backup system to pull backup out and push it to S3 like regularly, so that there's a system to put those back in place, within 15 minutes if one's down. So yeah, there's still a case where there's like some small outage, but I think the alternative is literally paying twice as much for hardware, and I just didn't want to do that yet. Yes, no, absolutely, yep, yep.
If you had many factors more queries, then it might level out versus.
Yep, yep. And then maybe this is too specific to the product, but we do have like, so the 12-month data, pretty much only a human would query that. But there's all kinds of things in the system, like we want to send people alerts automatically. So that 30-day one is actually getting like hammered by crons and things too. That one has so much. That's why that one has so much more RAM per everything. It's just, I mean, it's like constantly being hammered. Like it's like pegged, but it responds super fast. It's awesome. I don't know, it's magic. So the 12-month one though, like I said, it's terrifying. If if the customers all knew and they all wanted to send a query to a different month at the same time, there would be an opt problem. So it's keep that in mind. Yeah. Like kind of field or? Huge to Boolean. So simple gender Boolean, right? To like the most common one is the timestamp, right? And so that's down to the second, and that goes on for the whole month or whatever, right? So trying to think if one would be any bigger than timestamp. I kind of doubt it. Username. Or user ID, which is hundreds of millions of users for a social network. Trying to think of others. Those are probably the biggest, if I had to guess.
How big is each document in general? Like, what is the range?
Like if I were to put it in JSON or what? I don't know how to.
Like size of each document?
Yeah, it's tough because a lot of it is created in the writer. So another thing we do is in the Solr indexer, a lot of, like, let's just say a tweet came in, right? The tweet has a lot of information, but we have tons more. We have like, we can guess at their gender and things like that I mentioned. That's a ton of data science models, and geo lookups, all kinds of things happen. And they all happen without doing any I/O because we're doing it at such a rate. So we do it all locally, and then the document gets a lot bigger before we put it in Solr. And so I never really even looked at I didn't never even think about it. I mean, like I said, there's 65 fields on here. Most of them are like Booleans and things like that, or small integers. For Twitter, you're only talking about 140 characters for the body, but we're doing other networks too, which can be huge. I don't know, a few K, I guess, if you were to like put it in the thing. I guess one 12-hour shard for the one that I'm talking about the examples of here is 80 gigs on disk. Yeah.
What's the Solr indexer that you're using coming off of Kafka? Is that something you guys?
Yeah, but it's maybe importantly it's on the JVM and it's using Solr because it's a lot better than most things. And then it's just yanking out Kafka. It's doing just stuff that we wrote that's important to us. Nothing special really.
Something like a cloud Solr server?
Yeah. We're depending on all the regular Solr class stuff. We don't do it. We never had to hack on Solr yet. So, yeah.
So, very basic question. What Solr do you use? Is it basically filter?
For the time stuff, I think the date one is just backed by a tree long field or whatever, but a try long or whatever. But I stuck to this integers like I showed here, just because it's easier for me to think about and type out. I never remember ISO formats. I hate them. So I just do the Unix epoch, whatever that example was. It looks just like those numbers, and so it's a try long field or try int field. Did I what?
Did your watch show you milliseconds?
Oh, I remember that day with such. Oh yeah, it was a good day. It was a good day. Yes, exactly.
How do you monitor the cluster?
How do we monitor it? For Spreadfast, Nagios, just a lot of queries that we expect to return results, like for each month or something like that, going back in time. Nothing too fancy. Like I said, for the Spreadfast example, which is the one I can give the real details about because it's not like confidential, the ops team and the development team was like one or two, so there wasn't a lot of fancy stuff going on as far as.
Something like graph
Oh, sure, yeah, sorry. So on the indexer side, tons of graphite stats, so we can see our indexing rate, delete rate, update rate, all kinds of things like that. So yeah, no, stats D and graphite for sure. Forgot about that. All over the place, littered. Yes. Go ahead.
I'm not sure if you answered this, but I'm wondering how you manage the life cycle, say something like that 30-day index. I mean, from today back 30 days, that's one time. But once you get the next day, how do you every day you generate the last 30 days? You got
No, I should have pointed that out. In both those clusters, the 12-month and the 30-month, they're actually being full real-time indexed. Nothing is being pulled out of one or the other because we need them both to be real-time. In case you need to do a 33-day query, that needs to hit the old cluster, and that cluster needs to have all the data. And in case you did a last 5-minute query, that one needs to have really recent data. So the indexing pipeline is completely duplicated to both those clusters. So the only life cycle part to it, to me, that I can think of off the top of my head is the crons that are periodically going, hey, should I delete like the last day of these two collections? Yes, I should. So it's just dropping old shards. The front is always being written by real time. Yeah, that's the gist. I can go into like a lot more detail there. It's like 2 minutes. Yes.
What type of GC output are you using? What will the pause times take?
So we never monitored the pause times. I honestly, maybe this is really rare, but I've not had GC issues really in Solr come up. My nightmare for that was Cassandra, but we never recorded them. We never noticed the query coming back like super delayed because of a big GC. And we were probably using, I'm sure we were using default. We didn't switch to G1, but I'm a big upgrader. I always upgrade the latest Solr. We always run the latest JVM. So we were running like 1.8 before we were supposed to, apparently. So like before Lucene apparently told us that we could. So maybe get some benefits from that, but I don't really know the pause times. I will say we turn up the new gen quite a bit because when it's being indexed, like that stuff's just churning. So maybe half and half is like half new, half old, because we're not keeping around filter caches very much. Most of it's all stuff that's generated for a query or it's generated for indexing, and so it's almost all new. I mean, half, which is a lot. Anything else? All right, cool. I'll be outside.